For the first time ever, scientists using NASA's Fermi Gamma-ray Space Telescope have found the source of a high-energy neutrino from outside our galaxy. The neutrino came from the eruption of a supermassive black hole at the center of a type of galaxy called a blazar. The eruption jetted out particles moving near the speed of light. Collisions inside the jet produced gamma rays, the highest energy form of light, and neutrinos, ghostly particles that rarely interact with matter. 3.7 billion years later, they reached Earth. On September 22, 2017, a single high-energy neutrino struck an atom in a water molecule in the Antarctic ice. The crash produced a particle called a muon. It raced through the ice so fast it emitted a faint blue glow. When the muon reached the South Pole, it was tracked by the IceCube Neutrino Observatory. IceCube scientists found the original neutrino likely came from beyond our solar system. They alerted astronomers to be on the lookout for cosmic outbursts possibly associated with it. NASA's Fermi Gamma-ray Space Telescope found the source, a blazar it had been watching for some time. When the neutrino arrived, Fermi saw the blazar was brighter than it had been over the previous decade. It's the first time a neutrino could be traced back to a black hole, or to any source beyond our immediate galactic neighborhood. And it's an important step forward for a growing field scientists call multi-messenger astronomy, which combines light with new signals like gravitational waves and neutrinos to provide new insights on the most extreme cosmic phenomena.